Professor Ying, I'm so grateful to be here. I'm from Stanford GSB, so I'm from a business background. I have zero coding experience. I seriously considered coding 2 years ago, and I write many agents. And today I had a great experience because I have no idea what a project would look like until I see it. And when I was really resonated when you this morning talking about the modularization of the agent. We think about prompt, we think about MCP, we think about all kind of things, right? Eval. So I'm thinking about there's evaluation for agents. Is there evaluation for agentic faster programming? What is the best practice? Because everybody using different tools, everybody use spec driven. And people talking about context engineering, not prompt engineering, right? And we come up with our own working process, but sometimes it's turned out very good, but sometimes it's not. So we really want to clear your your perspective in terms of what we can, make us, do it better.
Right. So maybe I'll share. I think best practice of AI-assisted coding, frankly, is evolving so quickly. Even today, listening to the panelists or chatting people in the hallway, I'm learning as well. So I don't know that there's any single world best experience because best practice is evolving so quickly, right? But I think some of the best practices I know about, test-driven development. But one thing I found is there's some components we know we build on top of, so test those much more rigorously. The things that you're not building on top of, like front end, I test that less rigorously, but back end database, I really test that because to avoid really weird bugs I can't find later. The spec is important. I find that fast iterations really helps drive product progress. I don't know. I think the question of how do you orchestrate multiple agents to work together, I see lots of different people doing lots of different things to coordinate. It feels like Wild West, very exciting Wild West. I think there's a lot of issues with MCP was a great step forward. The challenges of MCP is a long flat list of APIs, and so I think eventually we need to evolve the protocols of more hierarchical discovery. So there's a lot of this going on. But so I think the AI. So one tip I have AI assisted coding. Actually, one thing I do a lot is try to read other people's prompts. It turns out that one of the ways I learned to be a decent prompting, hopefully, is whenever some system prompt is leaked on the internet, I will go and read that. Whenever there's a research paper really cool result, I will sometimes go and download the open source and go and read the prompts, because I find that a lot of people, the only way to be good prompting is try yourself and also read other people's prompts, as we say. One of the things about evals, so agentic workflows, which is a little bit more mature, one of the biggest factors that determines your ability to build an agentic workflow like is the ability to drive a disciplined error analysis process. And this is surprisingly long. But the best practices is some agentic workflows, you have an AI agent that, for example, download a PDF, extract the text, do a web search to check if you're working with someone that's sanctioned for some compliance thing, you work with database and pricings and So these agentic workflows, I find that the ability to quickly build an end-to-end workflow and then have evals at the end-to-end workflow, and then to also do error analysis so that when the AI agent doesn't do what a human expert would do, to really carefully attribute the gap between the agent and the human to which component is misbehaving, so you can focus attention on the right component to work on. Right now, I see still very large differences between the team's skill in driving a discipline error analysis process. Then you're not guessing what to work on. You're the complex agent can diagnose where the hotspots are and where it's underperforming and really focus attention on that. And it comes from having an eval set and being very systematic and looking where's the AI agent falling short of what human experts would do and using that to focus attention. It just seems I wish you could teach that to all people, but it makes a huge difference to the velocity of the team.
Hi. Any question?
And what are the limits right now for this AI coding? Like we can see it's creating SaaS applications, which we have been seeing. But what about like large backend softwares, like how RDBMS is made? Do you see AI Because it may not take, like decades to make databases now. I mean, do you think it's possible, like, to get a lot of help from this?
So I think Paxton from Anthropic, right? I think he said that a lot of the Anthropic researchers haven't written a line of code by hand for a long time. So I think we are seeing really serious software, being written with AI coding agents. What I'm seeing is that, I don't know, for the more common tasks, like normal front-end, back-end development, there's the more training data, and so it's really great at that. For writing really weird research code, it turns out, by the way, it's pretty good at implementing a transformer neural network, right? Because there's enough data on that. But for really weird corner cases or some types of low-level GPU programming, there's less training data, and so they're actually less reliable. Or for real corner cases with building very weird research algorithms that no one else has implemented, you need to go low level in your prompting. Whereas for a front end, there's so many React front ends where you can do the high level prompts, usually pretty sensitive as some reasonable interpretation. And then it turns out that I don't know, if you look at a lot of the recent progress, the models are getting really good. So I think Cloud 4 is an amazing model, GPT-5 is an amazing model. But I find that a lot of the power of these is not just a model, it's an agentic group that, the cloud code like Gemini CLI or Replit or whatever was wrapping around these models. I think there's an interesting study showing that I don't remember the citation. There's a really interesting study showing that if you look at tasks that humans can do, kind of 2 years ago, AI could could maybe complete tasks that humans would take, 30 seconds to do, and AI could do that reliably. And what's been happening is tasks that take humans a minute, 5 minutes, 10 minutes, 20 minutes has been kind of doubling of how difficult a task is as measured by how long a human needs to do it, that now AI can increasingly autonomously do. So that has been a very exciting trend, that kind of a rapid doubling of how much code can a human write in a certain amount of time, that now AI can do autonomously.
Thanks.
All right, any other questions, please?
So from agentic coding, AI is the new electricity, all the way back to deep learning on deep unsupervised learning using graphic processors. What's another Andrew Ng belief that the world hasn't caught on to yet?
By the way, part of me misses the days that I would say something and then nobody would believe me, right? And then I remember when I said we got to scale up, machine learning algorithms, more data, a lot of people did not believe me, right? And then I just worked on it quietly for myself for a long time, and eventually people came around. Now I'm actually worried that I might say something dumb and then people believe me. Yeah. I think for the next few years, there's a lot of work to be done to take a lot of enterprise workflows and implement them as agentic workflows. There's one thing I think is exciting. I think people still underestimate the power of the voice stack. I think in the future, there'll be a lot more voice-based applications than is widely appreciated now. I think visual AI is also coming a little bit slowly. Landing AI is seeing that agentic document extraction. It turns out, surprisingly, the most valuable type of images of PDF files. Someone told me that humanity generates more than 1 trillion pages of documents per year, and so agentic doc extraction is really taking off like that, right? The ability to extract separate PDF files for downstream processing, like really seeing, kind of classic, really rapid growth, organic or not. Yeah, so it feels like a lot of work to do. Maybe one other thing. One thing that people don't believe me on yet. I think everyone should learn to code, not just software engineers.
Thank you.
Do you mean learning to code by yourself without agentic help, or doing it with agentic?
Right. I'll repeat the question. So people should learn to code by hand or with AI assistance. Learn to do with AI assistance. Yeah, but it's just on my team, the AI Fund and DDon.ai, everyone's learned to code. I see a lot of people whose job function is not a software engineer do things that are much more effective they're not becoming software engineers, and nor do I believe want everyone to. But yeah, when non-technical people in non-technical roles learn to code, you're a better marketer, you're a better recruiter, you're a better HR professional, you're a better finance professional. So I think the world will still need quite a bit of time to figure that out.
Thank you, Professor. So, a lot of these models that are used today have been trained on software that's already been written. Now, in future, how will new patterns of software building emerge and propagate into these models and become widespread? What's that mechanism going to look like?
One thing I wonder about, so in computing, we build layers of abstractions, and then sometimes there's some low-level abstractions that are, okay, right, not great, like pretty good, but we just leave it alone and we just build on top of it. So for example, I think Linux is amazing. On the other hand, I don't know, we're probably stuck with it, maybe in perpetuity, right? Like it's okay. Maybe there's an even better OS to be invented than Linux, but there's so much built on top of it, probably not worth trying to change it at this point. So part of me wonders, like the 8086 assembly, right? Frankly, like we're probably stuck with it for a long time, but it's okay. So part of me wonders, with so much code on the internet, on Python and JavaScript, will Python and JavaScript, be the abstraction layer, and maybe C++ and Java or whatever, for a long time? Or, and I think it'd be okay if it is, because it's not that bad, right? But if someone invents a new programming language, that's okay too. I do see what I mentioned just now. A lot of struggle with low-level GPU programming because the data is in there, and so yeah. I understand. One interesting thing. So the Llama paper, the Llama 3.1 or 3.3 paper, so I forget. Talked on using an earlier version of Llama and an agentic workflow to basically generate coding puzzles. So the AI think for a long time to generate coding puzzles and solutions, and this generates data to train the next generation of model that where it goes to solve the same coding puzzle very quickly, right? To just generate the output directly without as long agentically. So I think that as AI systems with agentic rules can take a long time to solve puzzles, this generates data to train the next gen of AI to try to solve that more quickly. So there's a path to synthetic data generation that I think is quite exciting as well.
Thank you, Andrew. I have one question. It is very open-ended. So, when we talk about LLMs, on a very fundamental level, it is the prediction of next token given the previous tokens, right? But when we talk about AGI, okay, nowadays people are like raving about AGI is coming. And when I sense, when I compare it with the human minds, okay, we basically think based on gut, based on beliefs, and there are a lot of other factors involved. But in order to reach AGI, where my mindset goes and basically the bottlenecks arrives, is the consciousness. In terms of like LLM or evolving it to the AGI, how do you think that this bottleneck, where it is right now we see it as a next token prediction, is going to be evolved in a way where model can surpass this bottleneck of just predicting the next output into predicting something that we as a human do based on belief, guts, consciousness. Like, are we too far?
Did you say conciseness?
No, consciousness.
Oh, consciousness.
Yeah.
Yes.
So this is something like very, to me it interests a lot. But at the same time, when we think of the current AGI or trend in the market, it always saturates to the point where no matter what we are doing, we are always predicting the next token based on the previous ones. So it's open-ended, and I wanted to know their perspective.
Yeah, so let me speak about AGI, the concept, and then talk about progress in AI as separate things, right? So I feel like, AGI has become a term of hype rather than a technical term. I think the original definition that I knew of was AI that could do intellectual tasks that a human can. And most of us can, learn to drive a car in a brand new environment, like the Safari, right, with a few minutes of training, or most of us probably learn to fly an airplane with a few dozen of hours, and I learned to, whatever, pilot a boat, right? So these are all tasks that humans can do. They're actually pretty far from AI being able to do. So I think actually very far from AGI as originally conceived. But for various economic or business or PR reasons, a lot of companies have been, tossing out alternative definitions of AGI to generate hype or PR or whatever. And what has happened is there are now so many inconsistent definitions of AGI that it's very hard to know what people are kind of talking about when people use AGI, which is why I suspect that when some company announces they reach AGI, I don't think there'll be a technical milestone or be a marketing milestone. And part of me, I feel like, if I look back at the sequencing of the human genome, it turns out that there were two groups that were competing on PR, rivalry, blah, 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 and eventually decided, let's just declare success. They have a joint PR conference, declare success, and then they got back to the real work of actually sequencing the human genome. So part of me tends to say, why don't we just declare we reach AGI? I don't even know what it means anymore. And by some definitions, I think got to AGI decades ago. So I'm actually really wondering, this might get me into trouble. Should you just encourage companies? Let's just declare success, and then let's get back to the real work of creating an AI. It might take some of the hype off the table and be a more healthy ecosystem. I don't know. I may get into trouble for that proposal. Let's see. Now, in terms of actual progress toward AI, consciousness, I don't know how to measure consciousness. Consciousness is an important philosophical question, but it turns out in philosophy, there's this sense of how do you know if I am conscious? How do you know if I have a sense of self? Or in philosophy, there's concept of a zombie. Maybe I am not conscious, but I just act as if I'm conscious and you can't tell. So I think we've decided in human society, none of us know if each other are conscious, but it's considered polite to just pretend the other person is. And I think that's, and I think I feel the same toward computers. To me, whether a computer is conscious is a philosophical question as opposed to a scientific question, because there is no test for consciousness that I know of. I'm not dismissing the importance of philosophical questions. They're important, but it will be a question that people can debate, for, I don't know, centuries without ever reaching resolution. And so the engineer / scientist in me, I'm just saying, I don't know if the computer is conscious, just like you don't know if I am conscious. And so if we look at the behaviors of computers relative to the behaviors that intelligent humans can do, there is still clearly a gap. But in some places, we vastly surpass humans. In some places, we're vastly inferior to humans. Computers are vastly inferior to humans. And so I think completely closing the gap to humans seems really difficult. I think it would be many decades, mainly because computers are designed around very different principles of biology. And so the human brain just some advantages that computers have a hard time matching. For computers, some amazing advantages that humans have a hard time matching. So I feel like what I'm ended up doing is, just focus on building stuff. Because
Thanks, Andy. I have a question on the topic which you previously touched upon. What does it mean for computer science people who are getting educated in colleges and universities? I know, of course, the obvious answer is everybody should start using these tools, be more productive on whatever they're building. But my question is on more fundamental stuff like, will it change the focus on what to learn in terms of computer science basics? Do you still need to know how to do the recursion of, say, Tower of Hanoi problem, or how to traverse the graph? Do you still go down over the wire to learn how the compiler design works? Or maybe questions like, maybe the programming or the languages being written now or in future will be specifically written for LLMs and not for humans to be learned and code. So I was wondering how a kid who is in college, his focus should be, in addition to using these tools, also building the fundamentals so he can extend the field of computer science itself.
So I feel like the things I learned as a computer science person, some of it is now obsolete, but not that much. So I think computer science degrees still teach a lot of valuable, useful information. The bigger problem I see with a lot of computer science programs is they don't teach the new thing that is super important. The curriculum hasn't adapted yet. And some is obsolete. So for example, frankly, like, don't ask me to memorize JavaScript syntax like that, right? It's just like, yeah. So there's stuff like that I think is much less important. But a lot of the computer science fundamentals, like understanding how is data stored, what is the database schema? How do these things scale or not scale? What is networking like? What is the abstraction layer? What is the stack they're building on top of? I think a lot of these fundamentals allow people with a deeper CS knowledge to still steer AI systems, to architect and build much more robust, scalable systems. I think out there, many of us have had the experience of, an AI coding agent do reward hacking. Like, I did this happen to you, right? Like, delete all the tests because it's the fastest way to pass your test. AI coding agents will do stuff like that. And I think people with that deeper computer science fundamentals are able to better think through problem solving. So I find that very valuable. And I don't know, my gut is the stuff taught in CS departments, 2-3 years ago, I want to say like 70-80%, or maybe 70% is still 70-80% is still highly relevant and worth knowing. But we also really need to add on this new knowledge that is incredibly valuable, which I think many universities are kind of relatively too slowly adapting to.
Hi, Andrew. Thank you for your keynote. Early in the day, you talked about the PM bottleneck, that problem of testing with the people and users and strangers. So I was wondering if you envision that we will use AI to actually resolve that bottleneck as well, like, prompting LLM to act as a product user persona and testing the app and things like that. So do you envision, and if yes, then how?
Yeah, so it turns out there are a lot of efforts on this. Actually, just now, Ash was grabbing me and showing me some product that does this. But turns out there's just a lot of research on using simulated agents to do user studies. And so a lot of the questions are, I could simulate 100 persona and even run a survey against a persona and even get answers and then test on my products. So a lot of the active, exciting research is how can I calibrate my crowd of 100 simulated agent persona? I can say, like a system prompt, right? You are this year, this type of person, this job, like tell me what you think. So how do you build this collection of simulated agents so that the answers you get back are well calibrated to what the population of users would do? I think is, but I think as a first cut, I think many of us, if I have a product idea, brainstorm, I'll get a first cut of feedback from just one default personality is actually already pretty good. So I think that research hopefully will continue. Oh, but there's actually one other thing. A lot of crowd of feedback is that the information, it doesn't exist on the internet. So for example, when AI Fund were building a lot of B2B products, we're working with, finance professionals or shipping tariff compliance professionals or something. And there just isn't a lot of data on the internet on how they will react to different product features. So in this case, the public LLMs, they just don't have the context. They just don't understand this weird job they're building software for. And then having some way to go and get feedback from the real humans with domain expertise is still important. Will we ever send AI agents to interview them instead of us going to talk to them? I don't know. I think it's actually a very exciting dynamic space. But given the product management bottleneck, I think I'm pretty motivated, right, to see if we can find ways to alleviate this bottleneck.
All right. Thank you so much, Andrew.